So yeah, I'm Chris Mader, and I am the director for Systems and Data Engineering at the Frost Institute for Data Science Computing at UM. And if you want to follow along, you could, like these slides are online, so if you wanted to follow them, you can follow that QR code. And so at the Institute we have, I'm just going to do this, I'm just giving the introduction. Oh, closer. So at the Institute we have basically our goal is to support creating like interdisciplinary research projects and supporting investigators at the university and outside. And we have two platforms, so they call them platforms. So one is, we operate a large cluster and have several clusters, petabytes of data and things like that. That's the advanced computing, and then there's the systems and data engineering group, which is my group. And we build software applications, data processing pipelines and things like this, from like HoloLens applications for XR all the way through to like clinical research with medical records and things like that. So we support lots of different projects, but it turns out lots of projects need work with geospatial data. And so these are examples just of some applications that we built and the kinds of data. So this is like ACS data with some Miami-specific affordable housing data. This is redlining data, historic redlining data, overlaid with some historic properties. Heat data and cooling stations with radii around them for the walking distances. Land use, elevation data like raster. So we have vector and raster data. This is projected sea level rise in like 2060 in the county. This is all Miami, Dade County if you haven't seen it. So that island is Miami Beach. The rest of that is Miami. We built a COVID tool dashboard, which is a different kind of data sets, which have maps and charts and things in them, and show data at different geographic scales. We've gone out and collected data. This is a project we did in Colombia. Community surveys, pull that data together. We also make maps. This is simulated turtle data. Like these are turtle migration, and you can do calculations of where these turtles are at. And this is this project we're going to talk about a little more in the presentation, but it's environmental justice. So this is related to displacement and gentrification in Miami. So development pressure and mitigating that pressure. So the thing is, on all these projects, we used to manage this data ad hocly on every project. So we would, each project would accumulate these geospatial data sets and put them together. And after a while, we wanted to come up with a way to do it more comprehensively. And so that's what this is about, is the geospatial digital spatial collections, which is this system we're building. And it has two goals, aside from just the data, is also we want to make portable technology that goes with the data so we can pull it off and use it on these different projects. And so Tim is going to talk about that.
So thanks for that introduction, Chris. And I want to also thank Ian for a wonderful presentation. Birds of a feather here, we're both librarians. I really appreciate that. And so for those of you who don't know, one of the things we do is I think everyone knows the pain of putting together a GIS project. At the beginning, you spend a lot of time collecting data. And we're trying to make geospatial data fair. If you've not heard this acronym, this is kind of a library term around particularly academic libraries about making research data projects findable, accessible, interoperable, and reusable. No? And so we've run into this problem where a lot of these projects are not fair at all. And so we're trying to solve that problem. And that's what I'm going to speak to you about today. And this is kind of where we're going. I have very little time, about a minute per point here, to go over a container-based architecture, how we are storing our metadata in a centrally located place, how we're using these reusable data packages that we can then move around and break off, like what Chris mentioned, how we're trying to be transparent about our ETL process, and how we're kind of shifting from a geospatial metadata schema to a more just data-ish metadata schema, and then how we attach on kind of well-known applications at the end of it to provide discovery services and other map-based services to this, and two little case studies at the end. And so, for those of you who know, this probably looks like just another repository, and to a certain degree it is. But what I want to emphasize is that what we're trying to do is to build something that is container-based and movable and cloud native, we're trying to build something based around a different set of metadata structures that aren't as complicated as the really painful GIS ones. And we want to, I had a third point, what was it? No, I'll skip it for now. There was another, no, I'll skip it for now. But anyways, we're aware that we're in the dangerous zone of just creating another thing that is perhaps reinventing the wheel. But at the same time, I think we're doing some things that are really interesting and useful. So I want to speak really briefly about this container-based approach. The whole idea is we have this system that provides these services, that provides user interfaces to these services, that has this application layer that serves as kind of middleware between the data store and the services provided, that has a nice data store that kind of is healable. One of the things I really like about this is that we're building this as a set of Docker containers managed by Kubernetes, and it's entirely open source tools. You'll see a little bit of a stray from that at one point, but it's entirely open source. And the whole idea is that Kubernetes, for those of you who don't know, is a way of managing lots of different applications on a cloud kind of platform. And it self-heals. If one thing goes down, it tries to bring itself back up without damaging the rest of the kind of the thing that's going on. And I find this is really useful, to have a self-healing set of containers that work together. And then have some tools that we can manage this with. And I want to highlight some of these tools. The first thing I want to talk about is actually the metadata store. You'll notice that we have our metadata store on Box. Perhaps not the wisest choice of places to keep our metadata. So this is the heart of GDS you're looking at right now. And you can see that we're looking at metadata. It's just a collection of stuff. There's two reasons why I really like Box and why I chose Box. One is, ooh, okay. So, whoa, it could be my computer. Hopefully it's just gonna stay. Anyways, you're looking at the metadata that we use that drives this whole system, sometimes on and off looking at it. But what I like about it is I can take students, they can do the first drafts of the metadata for me. So as we all know, this is really difficult work to create metadata that's really well done. And so I can get students to do the first drafts. I'm just ignore the fact that the screen's flashing. Hopefully no one has like ADHD or anything that's gonna get weird. But the other thing I really like about it is it has multiple things. I can read this from the applications, from the management applications. It has all the crosswalks in it too. So I can, I can use this from the management tools. There's an API that I can use that gets into this. So we can edit it in real time and it shows up immediately through the management tools that we're using. It could be anywhere though. It could be in postGIS. You know what, I'm gonna try an experiment. I think I'm gonna just unplug and replug into a different port here and see what happens. Let's hope it stays. So the other thing that's good about this, so it uses all that metadata to parameterize scripts that we run on this ETL pod. And that ETL pod, it has no data on it. It is just a small container that has the GDAL OGR tools on it, which for some of you who know, it's the kind of the Swiss Army knife for command line computing and GIS data. And we're doing everything with the GDAL tools on that pod, and then it does two things. It either loads it into a postGIS pod, and this idea, we keep each data set on an individual pod, and this came from a group called Crunchy Data, who are some of the maintainers of postGIS, and they suggested, we floated this idea with them, and they suggested that we do each one, because then we can spin up and spin down containers as we need them, based on use. So the popular containers remain up, the less popular ones we go through time, we can take away those resources and make them available to other things. And the other thing it does is it writes to a storage volume that's kind of accessible to the whole cluster. And what it writes to that volume is the metadata and a kind of a data package. And this is kind of these reusable data packages that I was talking about, where it's basically just a folder with some stuff in it. has the original download, has the process steps that were taken. So if anyone wants to look at that, they can look at the process steps between the download and what they're actually looking at in the data store. And then we write various flavors of metadata based on those crosswalks that I showed you from that file. We also write, this is the process steps here, where it writes documentation. So if anyone really wants to dig in, they have available the actual scripts that are being used to ETL the data and anything that's taking place on the SQL side if they want to look at that. And then this is the metadata. I really appreciated that IIIF shot. We're doing something not like that, but I think that's where we're looking to go, is to make this kind of stuff available to various different things that could then pick it up and use it, including, I mean, we're looking at several different things. This is definitely a work in progress right now. So that's kind of what's going on at that data store level. And then once everything's there, there's two kind of points of access between the data store and the application layer. And one is a postGIS proxy, which means that it can connect to all those various pods and remain constant and provide services to those various pods that come and go. And then there's several applications that attach to that permanent storage volume, like a tile server or a solar index for search application. And you'll notice that we are building out, an Esri compliant set of services. This is the one non-proprietary part of this, but we feel it's really important to meet the needs of that community as well. And then when you come to the services, we put a portal on top of that. We have, basically you can attach various different applications. This is what Chris was kind of referring to with all those different projects. We can now attach all those different applications through some kind of API to either the postGIS proxy or through that the permanent data store to any number of web mapping applications. And then the GDSC interface, which is kind of a user interface for finding data. And with this, we have this ability to for flexibility and scalability. This was one of the real key things about trying to build this out, was that we could then reproduce this in two directions. One is that we can it's relatively easy to spin up entire instances of this. All the code's on GitHub, and we are looking for people to, if you're interested, it's not a public GitHub just yet, but we are looking for partners to think about this and how we can make it public. And you could federate this, including federating the metadata and then making it something like GeoBlacklight. For those of you who know what that is, I was somewhat inspired by that work to create a federated metadata store for GIS data that is not just, they had a different set of products and services that they were focused on that focuses more on this kind of academic data. And then the other way you could scale it is you can break off little bits that are useful. It's relatively easy to say, I want this, 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 and this, and I want to spin up another instance of that and serve it to this application as a decoupled instance of it that then, whenever you need to, you could update that data relatively quickly. And this is for those local applications that we were talking about. And we're going to talk about two examples here, the ODC GIS and the DVMT, which Chris mentioned. So as these services come out, these are live. I'm going to let you, if you want to explore these, and there's an Esri portal, and I have an instance of that running. So this is actually coming from the data store. I pulled it up already just because I knew I was going to have that same problem you were having. And so this should look familiar to most people familiar with ArcGIS Online. It plugs very easily into that whole kind of enterprise GIS infrastructure that they provide. And we've set up some servers to handle that infrastructure. We also have, I want to show this because it's actually kind of cool. The FAST API is a way of querying the SQL databases directly through an HTTPS interface. And when you click this, we're actually querying the database directly. Let's see if it works. There we go. I just queried the database that's on our cluster and got back the closest addresses to what I wanted to get there. And so you can then use this in some kind of application at the front end in various different ways, and it just returns it as JSON. Fast API is a very cool little tool that I found in part of this. So you can plug that into many different web mapping applications. And then I do want to show just the user interface. So it looks like kind of any repository-ish kind of user interface. You can see the collections we're working on. The DVMT is the first one that we've done. The camp is one we're working on right now, and they kind of cross over. This was one of the problems we were trying to solve, is that a collection or several collections might share several layers. And so we wanted to provide a way to provide those different services. And you'll notice that some of these aren't spun up right now. They're not live on the server. There's no pod that's running it right now. But for the DVMT, all of these are live, and I can search for things like poverty. One of the things that I'm particularly proud of on this is that we're handling attribute level metadata in this search engine, and it shows me which data sets have those attributes that are going on. And I'm going to look at this. We're also doing time series so that people can do longitudinal analyses and providing this. And if you dig a little bit deeper into it, you can actually see all the attributes. So this was a custom query from the APIs at the NACIS that we designed with this research team. And it's relatively easy now to set up custom queries to the ACS. And we're working on various things with these where you see all these. You can see the variable that has that in it might be useful. We have a vector tile server, which is very cool. This actually comes straight out of Crunchy Data. This is coming straight from the database. These are rendered live. And so this could also get plugged into some kind of application. Let's see where I'm here. I'm over here. You have all those access to the ArcGIS services. And you also have access to a query where you could actually get the stuff from a census tract just as information if you want this from your application. So we're trying to provide all these kind of services in various different directions that are available through this. I think that's all I want to talk about here, actually. And I'm going to go on to these two case studies. So the DVMT is the Displacement Vulnerability Mitigation Tool. And the whole idea behind this was that there was a research group that was thinking about social justice, and they had a student who would basically go through every single layer manually and pull the data out of it and build an index around displacement vulnerability for this. And what we did is by providing these services, we could then automate that entire process. So something that took 3 hours for a student to do now takes literally about 30 seconds to do. And community groups and developers can now use this to kind of assess their neighborhood based on this index that this research group put together. They put in some basic information about the place they're interested in. Everything kind of auto-populates from those services that I showed you, and it builds an index around vulnerability and displacement, and then provides to the developer a set of mitigation actions that could be taken, and to the community a kind of an idea of where they are. And this has reduced their time enormously, and this is actually going live like very soon. I mean, it's kind of live right now, but we're waiting on like some security stuff from the university to make it go fully live. And then the ODSI, so I really want to give a shout out to this group. This is a group that works with electronic health records, and they have a really robust system to do analytics on health outcomes of all kinds. But they have been struggling to incorporate GIS data with the EHR stuff. And so I've been working with them for several years, and they've contributed a lot to the thinking on this, about how this is going to be built and works. And we have this, and I have a local version running on my local host here, and it works very similarly like what we're doing. And this is that federated kind of example, where this is now a copy of the whole thing. I can search for poverty here, and go in, and this shows, and this shows where I find it, and I can actually click this and load the data. My waiting thing is a little wonky, but it just ETL'd that for me using that, and I think I'm going to leave it here because I'm being told to end. So this is where I wanted to end. We're kind of going in this direction, and I just want to shout out to all these wonderful people who have helped with this.